Today's objective, we will find pressure, volume, and temperature using the combined gas law. Remember, as pressure of gas increases, volume decreases. Indirect relationship, so as one goes up, the other goes down. So, if you see pressure and volume, you need to draw arrows like this. As the volume of the gas decreases, so volume goes down, temperature goes down. So we have a direct relationship. As pressure increases, temperature increases. This is also a direct relationship. And finally, how do we find Kelvin if we have degrees Celsius? Add 273. When we do that, we get 296.5 Kelvin. Alright, now that we've gone over that short review, that was talking about Boyle's, Charles, and Gay-Lussac's law. Now we're going to combine all these together into one formula. Now, if you remember Boyle's law and Charles' law, we have these equations. We have P1 V1 equals P2 V2. And then we also have the V1 over T1 equals V2 over T2. For the combined gas law, we just combine these equations together. So P1 V1 will be at the top, T1 at the bottom. What do you predict will be on the other side of this equal sign? P2 V2 over T2. Example 1. A sample of nitrogen gas goes from, here's my first volume, 2 always tells me it's my second, so second volume. Its pressure increases from, so that's my original pressure, 2, that's my second pressure. The final temperature is in Kelvin already, woohoo! But final tells me this is my second, initial tells me I'm looking for my first. I'm using this equation, plugging it in, I have P1, which is 100, times V1, which is 21, over T1, which we don't know, equals P2, which is 14, times V2, which is, we have V2, which is 14, times P2, which is 150, over T2, which is 300. There are a couple ways we can go through this. You choose what's right. I'm just going to do what I see is as easy. I'm going to multiply. So I see 21 times 100 gives me 2100. So over T1 still. 14 times 150 gets me 2100 over 300. Then I cross multiply. So 300 times 2100 equals 2100 times T1. Divide both sides by 2100 so that way we isolate for T1, because that's what we're looking for. And we get that 300 Kelvin is our initial temperature. Here's a trick. We can use this equation for any word problem. All you have to do is cross out what's not important. So, for example, a storage container holds, here's my original volume at my original pressure of 2 atm. If the pressure is increased to, well, that's my second pressure. At constant temperature, what will be the volume of the gas? So I'm looking for my second volume. Constant temperature. Does temperature change? No. If something doesn't change, is it really that interesting? Not really. So we're just going to cross it out of our equation, which leaves us with this equation. So example 4, P1 V1 over T1 equals P2 V2 over T2. Here's temperature 1, has a volume of the original volume. The temperature is increased 2, so that's my second temperature, 327 degrees Celsius. New volume, second volume. What is not mentioned? Pressure, so we can just cross off pressure, and we're left with this formula. And then we can go from there to solve.